So welcome to video 8. We're going to look at drawing histograms and other graphs from a frequency table. And I'm going to use the data from problem 27 in your textbook about newspaper or magazine reading times, what I called it last time. There are 5 classes. We created these classes and there are the frequencies for each class. So we're going to use this to make a histogram and show you the different parts of a histogram. Okay, here we go. So the first thing we want to do is we want to find the class boundaries. And the reason because is if we draw a bar graph, which with each class representing a bar, say we think of this as qualitative variables, and then we draw the frequency height on the bars, then that'll work pretty well. But the problem is these are numerical measurements, these classes, and 7 really includes all the numbers that have a 7 in front of it in general. And so what we want to do is there's a gap between 7 and 8, 15, 16, 23, 24, etc. And so what we want to do is move beyond the gaps that might show up between these numbers. And so the way we do that is we use class boundaries. Now, what's a class boundary again? Well, it's essentially halfway between the upper class limit of one class and the next class's lower class limit. So in our case, these numbers are separated by 1, so you just need to go halfway between to find the class boundary. And then at the ends or at the bottom, you just subtract halfway that matches all these boundaries you make here. So what we're going to do is we're going to find those numbers. All right? And here we go. So this one, this one is going to be 7.5. This is 15.5. This one's 23.5. This one's 31.5. And this boundary is 39.5. As you can see, 7.5 is halfway between 7 and 8. And then what we want to do is we want to put the boundaries on the other side. Negative 0.5, 7.5. Again, going halfway between the areas. And what happens is this is going to create bars on our histogram that actually touch, because the top upper boundary here matches the lower upper boundary here, so they're going to touch. So I just wanted to show you how I got those numbers so you can do it. You can basically do it by adding this upper class limit and this lower class limit and dividing by 2, and that'll give you the upper boundary and the lower boundary of the next class. So all the elements of a histogram, first of all, happen when you create this graph that I have drawn for you. And so what I want you to see is that in this graph I have on the y-axis I have drawn the frequencies. Now these frequencies could be labeled as percentages, then they'd be a relative frequency, or they could just be the counts like I have listed here, and they'd then be a frequency. So this is going to be a frequency histogram, not a relative frequency histogram. And then on the x-axis you want to list your classes, and you want to do that by listing all the class boundaries all the way through. Start with the lowest class boundary and then listing all the way through the highest upper class boundary. And then what happens is each histogram then is between the 2 boundaries. And I'll show you how that's done. So what we have is our frequency is 8, which is up here, and it goes between negative 0.5 and 7.5. And then the next frequency is also 8, goes up to 15.5, and then the frequency is 3, and then 3, and then 3. And that's all a histogram is a bar graph that looks like that. But notice every bar on a histogram has the same width, and then the heights are equal to the frequencies or the relative frequencies. And that's the most important part about a histogram. Also make sure you label your axes as to what they are, whether it's a frequency or relative frequency. In our case, it was problem 27, minutes reading a newspaper. And so you want to label those things so people, when they look at it, they understand what they're looking at and they know what it's about. And then sometimes you can even put a title. This is the amount of minutes people take when they're reading the newspaper on the internet, or whatever it happens to be. Okay? The bars must always touch, must always be the same width. If you have any questions, now would be a good time to write them down and ask them in class tomorrow. So now what I want to create is what's called a frequency polygon. And a frequency polygon is just going to put a dot at the class, excuse me, pardon me. Yeah, I'm sorry, got a little tongue-tied there. What you have to do in this case is you have to find the class midpoints, and you want to plot from the class midpoints. So if you remember, the midpoint from 0 to 7 is 3.5. Sorry, I got to change my pen tip. 3.5. And the midpoint from 8 to 15 was 11.5. 16 to 23 was 19.5. You just add them together and divide by 2. 27.5 and 35.5. And so these midpoints, I'll make little yellow vertical lines to mark where the midpoints are in my classes. But everything about this graph is the same, except that what you do is at the midpoint you plot the frequency. And this is not an exceptionally good graph for this, but you basically make a dot, and then what you do is you connect those dots. And this would be what's called a frequency polygon. Okay? So pause, see if there's any questions you have, and then we'll go to the next thing. Okay, so look, we got the same graph, so let's do a relative frequency. And if you remember, we had 25 newspaper readers, and 8 out of 25 was 32%, 8 out of 25 was 32%, and 3 out of 25 was 12%. And so what we're going to do is construct a relative frequency histogram. So this is relative frequency. That means these things are in percentages, so I'll put 10%, 20%, and 30%. And then I would go and graph these. So again, between the lower boundary and the upper boundary, I would come up to 32%, and down. The next class is 32%. The next class is 12%, then 12%, then 12%. And you'll notice a relative frequency histogram looks just like a frequency histogram. The only difference being is the labels on the y-axis. Okay? Any questions? Write them down, bring them to class tomorrow. And so to end this up, the last kind of graph we're going to do is called ogive. So the first one was a frequency histogram We did a relative frequency histogram third. In between, we did a frequency polygon. And now we're going to do an ogive, or ogive, is how people say it. And it uses what's called a cumulative frequency. So if you remember, the first class had 32%. The second class had 32%, but we add it to the first class, so we get 64%. And the last three classes all had 12%, but we add them one at a time to get these percentages all the way down. And what an ogive represents is how the percentages increase through classes, and you can kind of see some nice patterns once in a while. So in the first case, the first class, at the class midpoint, again, we're going to use these midpoints instead, which I'm not writing again, but you can see that that's where they'd be on the graph. Is I would go to 32%, which is right about here based on my label. And then at the next midpoint, I would go up to 64%, right about there. At the next midpoint, I would go to 76%. At the next midpoint, up to 88%. And the final midpoint would be 100%. And so what we can see is as we connect these together, and you could basically say it started from 0 if you wanted, where you had no data. But what we see is a kind of a growth rate, and you can see that it grew really fast from below here, from 0 up to here, and then the rate slowed down, only growing 12% a year. And you can kind of see what happens as you go through classes, not year, but readers up to higher levels. There are fewer and fewer readers who read at more minutes. And ogives sort of give us that impression. And it's sometimes called a cumulative frequency graph as well. Okay? Alrighty. And just as a final mention, your textbook has an example of each one of these. It also gives guidelines for each graph. And so you might want to take some notes on those and write those guidelines down. And by writing those down, that'll help you to remember what you need to remember in order to do these graphs. Okay, we shall see you tomorrow in class.